Well, hello and welcome to today's Advanced Reactor Roundup, where we are going to explore the state and prospects of U.S. SMR development with senior executives of 4 advanced reactor development companies, each with their own unique technology and set of use cases. I'm Craig Piercy. I'm the CEO of ANS, and I'll be your host and moderator this morning. Today's program is sponsored by the ANS Trustees of Nuclear, our premier utility and supplier partner program. Together, ANS and the Trustees of Nuclear are committed to expanding nuclear STEM learning opportunities in our schools and improving the public's understanding of applied nuclear science. For more information, visit ans.org/trustees. Some quick notes before we get started. If you have any questions, please type them into the Q&A function of Zoom. I'll attempt to address as many questions as possible. But of course, time will be short today, so I may combine a few together. The event will be recorded, and a link to the recording will be emailed to the event registrants by tomorrow. Additionally, significant certificates of attendance for the event are available by request. Please see the chat for contact information. And finally, we ask that all participants adhere to the ANS Code of Ethics and Respectful Behavior Policy, which can be found at ans.org. So with those notes out of the way, I'd like to introduce today's panelists. Joe Miller is the president of BWXT Advanced Technologies, where he heads the effort to deliver the Project Haley Advanced Microreactor demonstration and its commercial microreactor product banner. Paul Hastings serves as vice president, regulatory affairs and quality for Kairos Power, where he leads the licensing effort for their high-temperature fluoride salt-cooled reactor. Jake DeWitte is founder and CEO of Oklo Incorporated, a Sunnyvale, California-based company developing and building small modular reactors. And last but not least, former fellow and vice president of global business development for XEnergy, Ben Reinke. Full bios are in the chat for you to read. So at this point, we're going to go around the horn here for opening remarks. I'm going to start with Jake. Each participant here is going to give 3 to 5 minutes, just a little bit about their company, their product, and their plans for the future. Jake, take it away.
Great. Thanks, Craig. Thank you, everyone. Excited to have the chance to share a couple updates with you all, and excited to be on the panel with this group of friends, colleagues, and peers here. So yeah, a couple kind of updates I thought would be useful to share, kind of a status on a few fronts. I think at the highest level, I'll just say I think it's a very exciting time with what we see happening in the advanced nuclear space. I think we see a confluence of so many factors that, granted, I'm still fairly young, but in my life growing up around this space, dating back to when I was a kid, I don't think I've ever seen all those factors in place. So very neat opportunity for all of us. Very exciting, I think, potential for us to drive forward in terms of realizing the real potential that nuclear technology has towards sort of its next iterations in front of us. The reason I say that is because I think it hits on something that's really important, which is you hear a sampling of us up here, and there's so much more opportunity than just what you're going to hear today that's out there and that's growing. So much so that it's actually kind of hard to fathom. And I think we'll talk more about that a little later. But just real quick at Oklo, by way of background and introduction. So I'm Jake DeWitte, CEO, co-founder at Oklo, like Craig said. I've had the chance, thankfully, to be around this technology for a long time, dating back to when I was a kid growing up in New Mexico. Got the chance to fall in love with it at places like the National Atomic History Museum, now the National Nuclear Science Museum. Got excited to want to work on it from a young age, and had a good chance to get exposed to a lot of different aspects of the industry, ranging from sort of the government side of things to the academic side of things to the industrial side of things. We started Oklo 11 years ago, almost, largely built around the idea that there's a lot of potential in thinking about sort of the opportunities, what you can do with next generation nuclear technologies, but packaging them up in business models that are a little bit different than what we've typically seen in the past, partly as a response to see what we saw happening and changing in the energy user market, specifically focused on an independent power production model where we design, own, operate plants and sell power through power purchase agreements. So a bit different than the typical licensing model you see out there. And the goal with that was it allows us at our small sizes that we wanted to start at, which I'll talk about in a second, to also offer a product offering basically the power that nuclear systems produce, and a favorable package for a lot of the energy users that we saw increasingly wanting to find ways that were easier and palatable for them to buy the reliable, clean, and affordable power that nuclear systems can make. So that's part of what set the stage for us to do that. The other thing is we wanted to build off the incredible technological progress that's been made driving, what I think as we call advanced reactors, but next generation fission systems forward, especially around what we particularly are working on is the sodium cooled fast reactor concepts. After sort of having the chance to learn a lot about this, growing up in the space and seeing the incredible activities done by those in our national research and development complex and our national lab complex about pushing these technologies forward and bringing them to readiness, in many ways successfully demonstrating things that proved out the fundamental operational and engineering features and benefits at plants like FFTF and EBR2. We saw a lot of maturity to want to build from. We also saw some inherent supply chain and economic benefits associated with that technology that we felt allowed you to sort of reduce the total amount of capital needed to realize delivering these systems from start of company to actually producing power. And that was the other thing about starting small. Small reactors are like very small reactors are fun and neat, but we wanted to start not small because that's just interesting in and of itself, but largely as a way to change how we can actually capitalize and finance these things going forward. So we wanted to start as small as we reasonably could, found a sweet spot, initially at about a megawatt and a half, but then saw after sort of market feedback on that proved as more like 10 to 15 megawatts is where people were pretty interested in terms of potential customers that we were talking to, wanting us to start. So we moved and started up at basically a 15 megawatt design, which is where we are now. That's our Aurora powerhouse. And the idea there was to reduce the total amount of capital needed from start of company to producing first power from sort of the multi-billion-dollar proposition you often see when you get larger than that. Not because that's a bad thing, it's natural and it's perfectly normal, and we should be obviously supporting and investing those things, but because we wanted to take out some of the uncertainty and risk around how you do efficiently capitalize that. Partly because we thought, hey, there's an appetite in private markets and public markets to finance these things. Let's see how we can sort of make that reality. And so that's sort of what set the stage for us to start there. And between those feature sets have kind of been building off that model dating back from when we started the company. We've been excited to sort of march through a bunch of different points. A couple things sort of late that I'll highlight here. We obviously are working forward on our first plant in Idaho that we've talked a decent amount about, but just for context, that's a full commercial plant supported by a Department of Energy site use permit, supported by fuel awarded to us from Idaho National Laboratory and the Department of Energy from the recovered EBR2 fuel efforts, which is pretty exciting. And that will be our first plant to be built out at Idaho National Lab. Very excited about that project. It's been something we've been working on for a while and supports part of our core view too, and finding ways to maximize how we can partner with the government and all the facilities, assets, resources, expertise that they have in ways that go beyond just sort of direct cost share programs. And so this is an example of that on many fronts. So we're excited about how that is progressing and how we're moving forward on that. We've been I'll give you a regulatory synopsis in a second, but we're moving, that's sort of in slate for first. The next things coming after that, we have 2 plants we've announced in Ohio that we're excited about. And obviously there's the Air Force project that's going in Alaska, that's going through the different procurement steps and processes there. So those are the ones we've been public about. We're excited about a pipeline that's growing. I can tell you that the amount of interest that we see, and I think many of our friends and peers at Piercy, is huge, just a testament to the size of the market opportunity. Just real quick on the regulatory side, one thing I'll say, we've taken a very forward-leaning approach on the regulatory front. Obviously, that's led to some fun things and some not so fun things. But the good news is it's how we make progress. Our view is, the NRC has long been capable of licensing next generation systems. We just wanted to find the most effective and efficient path to do that. And so we've been really proud about how that sort of progressed from a pre-application space through piloting an application around LNP in 2018 to 2019, submitting an application in 2020. Sadly, we submitted that application on March 11, 2020, which was the same day the pandemic was declared, and that kind of screwed some things up, I think. After the denial of that, sort of going back and saying, okay, what are the open items that we want to address with them, and then focusing on pre-application in the last, really at this point, about 2 years, to sort of work through and close those out to ramp us into preparing for pre-application readiness assessment, and then ultimately submitting an updated, well, really a new application for the Idaho site, followed by the other sites we announced. And we're doing a Part 52 all-in-one combined license approach because we're an owner-operator. It allows us to do that, and it's all commercial on this front. So it's been exciting to see how that's progressed, and also just see from when we first started engaging in 2016 to now, how all that's kind of evolved forward, and also how the whole industry has been moving these things forward. So the last thing I'll say is we're excited about also some recent news. Look, the investment markets are very excited about nuclear. We announced last summer a partnership with AltC, special purpose acquisition company vehicle led by Sam Altman to go public through. That process, obviously, that takes a lot of work, takes time. By the way, learning about SEC regulations and comparing that to NRC regulations are pretty interesting. I think both parties can learn from some of that, as we all can probably. But we are proceeding at pace on that, and rather pleased to see how the response has been moving forward on that front. So yeah, look forward to questions after this. But thank you guys for the time. Thanks,
Jake. A lot of questions for you, but I want to keep going around the horn here. So feel free to turn your camera off, and I'm going to call Peter Hastings to the podium now. Peter, welcome. Give us a few minute backdrop on Kairos, what you're doing, what your products are, where you think things are headed.
Thanks, Craig. Like Jake, I'm honored to be part of this August group, providing an update on some really exciting times that, frankly, I never thought we'd see during my lifetime. I'll provide a quick background on Kairos Power for anyone who's unfamiliar with us. We're a mission-driven company, and as anyone who's ever seen a Kairos presentation will recall, we keep that mission in front of us in everything we do. That mission is to enable the world's transition to clean energy, with the ultimate goal of dramatically improving people's quality of life while protecting the environment. Kairos is an ancient Greek term for the right or opportune moment. And for us, that moment is the upcoming retirement of a really dramatic amount of natural gas fuel generating assets. We believe this will drive a huge demand, and with the urgent need for non-carbon emitting technology, we believe we're an essential part of helping to meet that demand. We're relatively young. We recently celebrated our 7th anniversary as a company. Kairos emerged from a DOE-sponsored integrated research project, and our co-founders who participated in that project concluded that the next logical step was to establish a private company to commercialize the fluoride salt-cooled, TRISO-fueled high-temperature reactor. So we're unique among TRISO-fueled machines in that we're liquid salt, molten salt cooled, not gas cooled. We've grown to nearly 400 employees over that time, almost all of whom are focused on technical work. We're based in Alameda, California, and also have a substantial presence in Albuquerque, New Mexico, with several smaller locations across the country, perhaps most notably the Oak Ridge site of our first reactor. We are privately funded. We're singularly focused on the FHR design and fully committed to design and license and demonstrate our technology through an iterative development and demonstration program. We're comparatively unique in our plan to own and operate our first reactor, the Hermes test reactor, which is scheduled to deploy in 2026, so just in a couple of years. Of course, as with many of my peers, this will require that we think differently about how to develop and deploy reactors. We want to be competitive with natural gas. That's our cost target. As to our status, over the past 6.5 years, we've stood up substantial testing, development, and manufacturing infrastructure in both Alameda and Albuquerque, including facilities for manufacturing salt, machining graphite, and prototyping fuel particle and pebble manufacturing. And that includes a partnership with Materion, the world's preeminent beryllium provider in Elmore, Ohio, who helped us pilot our salt manufacturing capabilities. We were in active pre-application engagement with the Nuclear Regulatory Commission staff for the past several years and submitted and received approval for 11 topical reports focusing primarily on methodological and phenomenological topics to sort of front load the most meaty issues as early as we could in the process to try to retire programmatic risk as early as possible. We applied for a construction permit for the 35 megawatt Hermes test reactor a little over 2 years ago and received that permit late last year, following less than 2 years of staff review. We expect to begin construction at the Hermes site, which is near the former K25 gaseous diffusion site in Oak Ridge, later this year, and also submit the operating license application for Hermes in the coming months. We also submitted a second construction permit application for Hermes 2, which will be a 2-unit plant immediately adjacent to Hermes, and will also produce electricity. And that's expected to not only enjoy an even quicker 14-month NRC review, but also an environmental assessment in lieu of a full environmental impact statement. That draft environmental assessment has been prepared. The draft safety evaluation for the safety side of the review has been completed with open items, and we're well on our way down the road on that schedule. Also, as a predecessor to the nuclear platforms, the Hermes reactors, our engineering test unit in Albuquerque recently completed over 2,000 hours of operation of the world's largest flight installation. It's currently being decommissioned and will be followed by ETU2, which is a follow-on iteration that's incrementally even more prototypic of the Hermes reactor. And then finally, in terms of our most recent accomplishments, we just concluded negotiations of our Advanced Reactor Demonstration Program contract with DOE. This is notable because of the innovations that we're piloting in contracting space with DOE in terms of milestone-based contracting. It did take perseverance and patience on the part of both Kairos and DOE to figure out how to do business differently, but it will definitely pay off in terms of efficiency and cost savings in administering the contract. So I'll wrap up there. I'm looking forward to the rest of the conversation.
Thanks, Peter. Same thing. Many questions for the panel, but at this point, go ahead and let's bring Joe Miller to the, Joe Miller, go ahead, put your camera on, put your phone on. Let's do a sound check and then fire away.
Hey, Craig. Yeah, so appreciate it. And I appreciate the comments from both Jake and Peter. It's great to be part of this webinar. So for my background, I started my career in the U.S. Navy and quickly moved from the U.S. Navy to the shipyard and then went into the high-tech industry for 6 years in semiconductor manufacturing. So I learned a lot about what it takes to mass produce semiconductors and understand how to transition from product development really rapidly into a full-scale deployment of new products. And so I joined BWXT about 13 years ago, and I was focused on understanding and translating all the requirements for a small modular reactor into a test program, using those requirements to develop good tests to understand the performance and really the personality of a new nuclear system. As I transitioned into this role, and Advanced Technologies was created within BWXT, we started looking at, from a manufacturer's perspective, what would it require to deploy new nuclear systems? What would they need to be? What are the capabilities and attributes of an organization that can go from an idea in a design to prototype to production? And we've been following that same strategic thesis since 2018 in Advanced Technologies. And we've grown rapidly too, because we started to see this desire from the US government, from the commercial industry on new nuclear systems. And that desire comes with very special requirements that are derived from the end use and the missions of each one of those end users. And as we developed our capabilities, we started to focus on things like computational engineering, new ways to construct and build novel materials, nuclear fuels, the encapsulation of nuclear fuels. You know, how can you more efficiently capture the thermal energy of nuclear fission? That was what we focused on for several years. And that helped us develop new techniques in the way in which we would go through the systems engineering process and build out new products. And our first marquee win was Project Pele. We've been working on that project for over 4 years. We won the design contract and the design competition 2 years ago, and we've been finalizing the design in parallel, putting all of the inputs to the PSAR process for the Department of Energy, in parallel making long lead procurements based on design finalization. We are taking receipt of those components. We are going through the quality control and verification of each one of those components, and we're building up not just the reactor, but a digital model of that reactor, so we can understand its performance, and we can translate all of this activity that we've been doing in design and supply chain development and deployment for the Pele prototype into a product line. And so we see, just like I believe the Strategic Capabilities Office sees Pele as the pathfinder for advanced microreactors for this country. And it's for the good of the country, both from a defense standpoint and also from a commercial standpoint. Energy security is extremely important to all humans. And so being able to provide a system that can be a very important piece to providing energy security is something that we take to be a very important responsibility for BWXT. You know, Craig, you had mentioned, you know, the translation of those requirements into commercial is also something that we're doing. So I have 3 verticals in my organization, one being the Pele vertical, hyper-focused on delivering the prototype, hyper-focused on ensuring that it is exactly what it needs to be when we field that unit at Idaho National Lab in the next several years. We'll be testing that reactor in 2 years, right? So this is real. This is being built. You can come and see it and touch it and see exactly what this reactor is going to look like here in Lynchburg. And then we have a separate part of my organization that's focusing on the commercial variant of a high temperature gas microreactor called Banner, BWXT's Advanced Nuclear Reactor. We've been fulfilling a couple of different important swim lanes on that, is looking at the performance and the costs of a microreactor as deployed in the commercial sector. So through the Department of Energy's Advanced Reactor Demonstration Program, we've made significant progress over the last several years. And we've made progress with understanding what the customers need. Once again, we have manufacturing capability. We have very unique and full design capability within BWXT. We went and asked the customers exactly, what does this microreactor need to do? What are you going to use the energy for? And that allows us as the nuclear experts, as the experts in delivering microreactors, what it needs to look like. So we've been focusing on that as well. We were able to couple all of that activity with another contract with the state of Wyoming to understand how these reactors would be deployed in the Trona Patch to be able to fulfill the needs of the mining industry. So the thermal use cases and the electrical use cases combined provide a very appealing use case for a microreactor of this type. So Pele, 1 to 5 megawatts electric. The Banner reactor is about 50 megawatts thermal, 15 megawatts electric. So having those 2 products in our portfolio, leveraging the investments that we've made as a company, leveraging the investments the government has made both through the DOE and DOD to be able to understand what the supply chain has to be, how you assemble these reactors, and how you deliver these reactors on a cadence that makes sense. You know, building one microreactor for the prototype is the #1 priority at my organization, but using that as a jumping off point to mass produce nuclear reactors is what my focus is long term. So with my experience in semiconductors, with my experience in the high-tech industry, coupling with my experience in nuclear engineering and all of the 160 years of manufacturing expertise within BWXT, we're coupling all that together to make microreactors a reality and working in the commercial segment, both in the mining industry, oil and gas, and obviously data centers is another end user that's very important to us. So as we go through this prototyping process, we've built up some very unique capabilities that we're also using for nuclear space. We have Project Draco that we're a subcontractor to Lockheed Martin on. So we are on the heels of delivering Pele. Within 18 months, we will be delivering the Draco reactor. So we're using that same mentality of rapid prototyping, the same mentality of quick transitions, meaningful transitions into prototype reactors for that segment as well. So with that, I'll turn it back over to you, Craig. But yeah, appreciate what others have said so far. Looking forward to hearing the questions as we go through this webinar.
Thanks, Joe. Looking forward to asking you a few too. So with that, let's go to our anchor guest here. Ben, take it away.
Thanks, Craig. First of all, thank you as well, as I think all of our panelists have said, to ANS and you for hosting this. It's a great opportunity to get to reach out to a lot of folks. And in particular, I am always gonna have a soft spot in my heart for ANS, which I'll talk about a little bit later. So great to be with you. And I wanted to tell you a little bit about XEnergy and then a little bit about why I'm talking to you today. So XEnergy is a company that was founded in 2009. We're in particular a high temperature gas cooled reactor design house and a fuel manufacturing company. So we have a handful of products. The flagship product is the XE100. That is a high temperature gas cooled reactor, produces 200 megawatts thermal and about 80 megawatts electric. That reactor is what we're taking to market as kind of our large first commercial product. It's grid scale as an SMR, and it's a Generation 4 reactor. We also have a micro reactor that we've developed under Project Pele, and we're excited to see what BWXT is doing in getting theirs to market. We have a continued award there to look at a commercial variant of our micro reactor product as well. We also do some work in space reactors and have designed space reactors of different types for different applications, whether it be surface power or for propulsion. And then finally, we have to have fuel to be able to supply all of those reactors. And so we have a fully owned subsidiary called CHYO. We manufacture TRISO fuel. This has been talked about several times already on this panel. But for those of you that don't know it well, tristructural isotropic fuel is a fuel that's based on high temperature tolerant ceramics that cannot melt in any scenario in reactors that are designed to use them. And that's the basis of our design for our reactor. Really all of our reactors, and for those that use TRISO fuel, you start with that safety case to try to design a reactor that's more economically competitive, simpler, faster to deploy, and allows you to achieve higher temperatures in the reactor during operations, which enables a whole host of use cases that today's reactors just can't touch. We have about 400 employees today. We're headquartered in Rockville, Maryland. So, just up the road a little ways from the U.S. Nuclear Regulatory Commission. That's where I am today, but we also have a large team in Oak Ridge, Tennessee. There we have a pilot fuel facility that's been in operation since 2017, where we make uranium-bearing fuel. We've made HALEU-bearing fuel, and we've made a bunch of surrogate material fuel that's operating inside the Oak Ridge National Laboratory under a DOE kind of regulatory banner. But we'll be deploying our first full-scale fuel fabrication facility down the road in Oak Ridge, Tennessee. And so our TRISO team is headquartered there with a good chunk of the company. We also have a permanent presence in Canada and the UK. We refer to those teams affectionately as XE Canada and XE UK, where we're working for kind of close following secondary markets for our products. And then, of course, we have a team down in Seadrift, Texas, that's on site with people rotating through all the time, but essentially a permanent presence now for our first project in Seadrift, Texas. We're deploying our first reactors under the Advanced Reactor Demonstration Program. I think Peter earlier mentioned that program. It was foundational to the establishment of what we see today as projects moving forward in the nuclear industry. Our project is in the top category tier, which is a multi-billion-dollar cost share for the deployment of our reactors. And that breaks into really three buckets. The first is a cost share for 50% of the non-recurring engineering. And that's a really important and impactful piece because it means that every dollar that we recruit into the company from private investment, we match that against a dollar from the US government in developing our IP and taking it to market. The second thing is for the overnight CapEx for our fuel facility. So as I mentioned earlier, we've got a pilot facility that formed the basis of the licensing and design for our first full-scale commercial fuel facility, which we call TX1. Or TRISO X1, and so that will cover half the overnight CapEx for that facility as well. And then finally, it covers half the overnight CapEx for the first set of reactors that we'll deploy. That's a 4-pack of our reactors, so 320 megawatt electric equivalent power plant that will be deployed in Seadrift, Texas, with our first customer. And I'm happy to talk more about that in a little bit. I also just wanted to say quick advertisement for the American Nuclear Society Congressional Fellowship, which I assume applications are open right now, I think, Craig, based on the year. So I had the great fortune to be an American Nuclear Society Fellow and learned a lot from Craig as a great mentor. I got to work with people like Brett on that in that experience as well. And then, of course, I got to throw out a thanks to Jake DeWitte, who in the advanced reactor space is one of the first people that I met. Jake actually testified at a hearing. It was the very first hearing that was held at the Senate Energy and Natural Resources Committee on the topic of advanced reactors. And I had the privilege of working with my mentor and good friend, Brian Miller, who was my boss at the time, to help put that hearing together. And Jake was one of our star witnesses. So I have a personal debt of gratitude to Jake. I took that experience as really a great opportunity to take technical experience and bring it to Capitol Hill, where it's often sorely missing. That's not true across the board. We have some fantastic people up there that handle the nuclear portfolio today, many of whom came from the American Nuclear Society Congressional Fellowship Program. So I spent a little bit of time after that on the committee staff as a permanent staffer, and then jumped over to the Department of Energy, where I ran the policy office and was the senior policy advisor to the Secretary of Energy. I moved to XEnergy about 3 years ago, where I led corporate strategy for 2 years. Today, I run our global business development efforts and advise our CEO. So thanks, Craig.
Well, thanks, Ben, and thanks for the shameless plug about the ANS Congressional Fellow Program. And I would note for those of you watching that there is more information about it in the chat. The application deadline is May 31st, so take a look. We have 2 positions open this year, so we encourage you to consider the opportunity. So at this point, let me ask all of our panelists to go ahead and come off mute, put your cameras on, and then let's kind of get into a little bit of a conversation here. So I want to start out by talking about what I think is maybe the sort of the biggest meta level news thing that's happened in the last few months, which is it seems like we've all woken up to this idea that electricity demand and energy demand is going to ramp up significantly because of data center use, AI use, large language models a little bit, but really image generation. It seems like after 10 to 15 years where we were in an overall demand growth of maybe somewhere between 0 to 2%, depending upon a year, we're looking at a much sort of steeper ramp for electricity production in the future. Jake, I want to send this question to you, but I want everybody else to have an opportunity to answer it. What are you seeing, and how significant is it to Oklo's long-term business plans that the demand picture for the future has sort of fundamentally changed? How has that changed the way that you're doing things or looking at doing things?
Yeah, I think that's one of the things that's wild to think about in retrospect a little bit. I remember as a grad student at MIT at the MIT Energy Conference, sitting in a panel that was talking about how demand is going to be flat for a long time. Well, then literally the following panel was about how electrification is going to drive a huge amount of demand, so change and increase. I think we've personally, and I think just generally, we're pretty long on energy abundance being something that people are always excited about, not just continuing to expand that, but also enabling that for the huge, the billions that don't have that at all. So the opportunity set alone just to meet what that piece was sort of, I think, staggering to think about. But I think what's happened, like what you said, Craig, is a sort of sharp recognition and realization of how energy can also directly impact things in ways that we're, as a society, I think generally a lot of times very excited about when new tools come to bear, just like what we're seeing with AI, which at the end of the day is obviously got a lot of, it's kind of crazy to think about the potential it can have, and we're just barely at the beginning of this. And I think what that does bring forward is a significant increase in terms of energy demand looking forward. And the numbers honestly break a lot of models that we've seen. We're fortunate that Sam Altman's been the chair of our board since almost the beginning of the company here at Oklo, and then obviously his role at OpenAI. We get to see some pretty clear signals of what the demand signals are going to look like. And I've heard folks who see the energy planning side look at this and talk about the numbers being on the global scale of needing to add about 100 gigawatts of new generating capacity per year to keep up with some of the potential expected demand that can be realized for the next 50 years. That's a crazy number to think about. And that's only on that front. I think that number might be, maybe that's a little aggressive. Maybe it's going to be limited by some other things in the near term, but that is a huge compounding benefit there. I think AI talks about chips being a big limiter, which is obviously part of it, but energy at the end of the day is going to be the biggest scaling enabler or limiter, depending how you think about it. But even producing the chips to meet what we need there needs a significant energy input, right? So that alone also creates compounding demand opportunities. And then when you add on top of that, all of the other things we see going on from first of all, thank you, Ben. That was very flattering of what you said. That was a very fun panel, by the way. But what Ben's talking about, what XEnergy is doing with Dow, thinking about how you're industrializing processes, not just decarbonizing industrial processes from heat as well as electric. Those transitions present a massive market opportunity. electrification of transit, electrification of domestic, heat use and gas use. All of those things are moving. And I think what the signals look like is there's so much room here. It's a massively daunting problem to solve. I think the challenge I think about in the nuclear industry is so often we think a lot about how do we get something built? And I totally get that, but we really need to be thinking about how do we get thousands upon thousands of these things built, because that's what the world is going to need from us. And especially if we want to match what we need to do from providing energy abundance while also enabling scalability and sustainability. And when I say from us, I don't mean just Oklo. I mean from all of us here and many, many others who might be watching or listening on this later. It's a huge opportunity set. It's actually really hard to put your mind around how big these numbers are.
Yeah, indeed. Anybody else want to jump in on this issue? I mean, Jake, you brought in the notion that added to all of this, now we're looking at decarbonizing sort of hard to abate sectors, right? And also looking at how do we make, because we know fossil fuels aren't going to go away overnight, right? So how do we make the production and use of those fossil fuels less carbon intensive, right? I mean, I think Ben, Joe, both of you are your reactor designs contemplate assisting in that process. You want to talk a little bit about that?
Yeah, I mean, it kind of goes back to why the state of Wyoming was so interested in the technology and identifying how you would create the infrastructure in the Trona Patch. So sodium carbonate mining industry is very important to the state of Wyoming, and it's really important to a lot of products that are made worldwide. And so decarbonizing that is important because right now in that part of the country, they rely heavily on coal, and coal is being phased out. Prices are going up. There's not energy security that like there used to be. And so how do you combat that, and how do you address that? And so having a reactor that you can ship this decade and be able to start that transition process in the near term is really important. And industrial end users, especially like mining companies and chemical companies and oil and gas, they're used to making big capital investments in securing those mines or those locations. So it makes a lot of sense. Furthermore, using the thermal energy off the reactor for process heat, plus the electrical energy off the reactor for electrification, you use both of those things, then the dollars and cents start to add up, and it starts to make a lot of sense from a financial perspective. And so that's why it's really important for what we're doing in our program is to focus on the reactor and the reactor design and how to get that thermal energy out of the reactor, and then what do the end users need so we can customize it for those end use applications. And we have a public agreement with Tata Chemical because they see the global impact of being able to have energy security in a very transportable package, and that relationship's going to grow, and it's going to grow into other relationships and other industries because of everything that we've discussed so far.
Well, and Ben, I mean, we see the tie up with Dow to the point where Dow has actually taken an equity stake in the company now. Can talk a little bit about that sort of confluence of interest between what Joe talked about, the sort of the unique investing opportunities with large scale industrials that are used to writing large checks with long timelines and are more maybe attuned to the pace of nuclear. Talk a little bit about that.
Yeah, thanks, Craig. You said most of it for me, so I'll embellish from there. No, I think Joe's spot on in the opportunity set. Just to put it in context, when we talk about total addressable market, today you're looking at four companies. Sorry, I'm bad at counting. Apparently, I forgot all my technical skills. Four companies that represent technologies that are all much smaller than a gigawatt scale nuclear power plant. Now, that doesn't mean that you can't put our reactors together and get to a gigawatt, but it means that you're not necessarily having to bite off a $20 to $30 billion project. But when we talk about the total addressable market, historically, that's been looking for customers that could take down the size and scale of a large light water reactor, gigawatt scale unit. And there are only so many of those customers that are available. And when you look in the US, those are very large utilities, typically in regulated markets. When you look abroad, they're often owned by the federal governments so that they can take on something that large. That's not what we're talking about here. We're talking about a whole bunch of different use cases. I think Jake laid it out very well with the business model that they've got, to become an IPP. That's a brand new use case and business model that has never existed in nuclear before. I would say what we're doing at XEnergy is similarly unique. So we always believed that these reactors had a host of benefits and advantages over what we've got today. And I love today's reactors just like all of us do. But there are things that they can't do, like achieving higher temperature process heat. Now, we always kind of assumed that your large nuclear companies would go first, your operators today would go first, deploying advanced reactors, and then we would see a pivot to other applications once the test case had been borne out. In our case, and I think for many of our competitors, we're seeing so much demand from the eventual end user of the real product, right? Our product is a reactor and our product is fuel, but we sell that to an intermediary that turns around and sells electrons. Well, in the natural gas industry today, that's not how it's necessarily done. Oftentimes, a power plant is owned by a heavy industrial, and they use that for the provision of both heat or steam and electricity. And so what we're doing with our first plant is actually deploying, as you mentioned, Craig, with Dow Chemical. Dow is, really the leading material science firm in the world. They make the building blocks of our daily lives. And when earlier, I think, both Jake and Joe framed up the long-term need that we're going to have to bring people out of energy poverty globally. Those people are going to demand a middle-class lifestyle, right? They're not going to just be sitting back and saying, it was great that we have electricity now, but we don't want to buy an iPad, or we don't want to, buy the various products that we have in our lives that make our lives great. And so finding ways to pull carbon dioxide out of those products in the manufacturing of them is really critical. Today in the US, about 25% of carbon emissions come from the heavy industrial sector. That's roughly equal to the electric sector, roughly equal to the automotive sector. So just putting that in context, we historically never talked about this. When Jake said that people said there would be flat demand, Craig, when you said it's been 0 to 2% for a long time, that's true for electric demand for traditional utility customers. So we're seeing this demand driving the need to go big on deployment of nuclear in a very large way with new applications. So our project with Dow, it's 4 reactors. One will be roughly equivalent of 1 reactor dedicated at all times to steam. That's the type of demand required at a large petrochemical manufacturing plant like where we're deploying, as well as a little over a reactor's worth of electricity. And so together, put that together, and we'll be pulling 440,000 tons of CO2 equivalent out of what otherwise would be produced from natural gas. There are 3 natural gas boilers today at that site. So we're super excited about that opportunity. And the last thing to say is just those customers, which, of course, we love our utility customers. In fact, our second planned plant that was announced is at Energy Northwest in the state of Washington, who operates the Columbia Generating Station today. But putting together those 2 separate types of customers, you've got an opportunity to take the advantages that we've seen in learning from how the oil, gas, and petrochemical sector have brought capital costs down for deployment, learning how to run mega projects extremely well, and the traditional experience of nuclear operators who know the nuclear industry, the safety culture, all of those benefits. Put them together, and we have, I think, a scalable deployment that will rival and ultimately beat what we saw in the 60s and 70s in the US. So we're really excited about it. And, there are a lot of other things I could say about it. I get all worked up. So
I like it. That was sort of a Babe Ruth point out to right field, right? That's great. Because I mean, again, the numbers seem to suggest that something like that is possible. Peter, I want to bring you into the conversation. So Kairos has taken arguably sort of a different approach to development of reactors. So much more focused on sort of multiple faster paced iterations of the technology. You're using the Part 50 process so that there's sort of less pressure on the licensing up front because you still have to get the operating permit, gives you a little bit more room to and flexibility to build. Where did that come from, and how do you think that impacts how you operate? How does that decision impact your sort of more practical decisions on a daily basis?
Yeah, great question. And the iterative approach that we use is actually linked to our regulatory decisions on the use of Part 50 versus Part 52 as well. It's really modeled after the ethos that was established when the company was stood up, and looking to companies like SpaceX for an approach to hardware development as a way to retire risk. Rapid iteration is really the hallmark of Kairos development. So rather than a monolithic multi-year development cycle that pours all of our resources into a one-time development cycle, we iterate in a ton of really countless design, build, test cycles that iteratively develop our design by way of actual hardware. So a component at a time. We'll develop it, we'll test it often to failure before we integrate it into a larger platform. And one of the real benefits of our test lab in our headquarters in Alameda, and then the larger demonstration tests in Albuquerque, is the engineers can come up with their design for their widgets in the office and then go right next door to the lab and actually fabricate it and test it. And that iterative approach occurs not only in the run-up to each of our individual development steps, or deployment steps rather, from discrete building tests, discrete testing platforms to prototypic demonstration platforms to actual reactors, but also in the sequencing of those major steps. So results from our test facilities, our discrete bench test facilities, feed into the integrated engineering test unit or ETU. Experience from the ETU, which is in many ways a prototype of the Hermes test reactor, feed into the Hermes test reactor itself. Lessons from the Hermes reactor feed into the next Hermes iteration, Hermes 2, and those reactors and subsequent and parallel test facilities directly inform the commercial plant, which we lovingly call KPX. As to part 50 versus 52, so both Hermes and Hermes 2 are non-power reactors by regulatory definition, and part 52 simply doesn't apply to non-power reactors. But even if it did, and in fact we started with a power reactor, and in the true spirit of rapid iteration, only pivoted to a test reactor about 3 years ago. Even if 52 did apply, we would still go with part 50 because of the construction uncertainty for first-of-a-kind designs under part 52, which I saw up close and personal on the AP1000 fleet. We do anticipate pivoting to part 52 in subsequent iterations, and we'll even evaluate the efficacy of part 53 when it's finalized to see if it ever makes sense to transition to that regime.
Mm-hmm. All right. So first of all, let me stop. Make an apology to our all the people that have put questions in the Q&A. We've got about 15 minutes left. I'm going to try to get, aggregate, synthesize, and try to include as much as possible. But so I'm going to try this with this first question. There are always challenges in building these plants and challenges in the supply chain. And I would include the provision of fuel and especially HALEU as part of that challenge. One of the questions in the Q&A is, for each of you, what's your biggest challenge? Is it fuel? I mean, I would let's sort of broaden it out to a more general challenges question. Is it fuel? Is it NRC? Is it supply chain development? This is some variation of what keeps you up at night. And then, hopefully you have a solution that you can talk about. But who wants to jump in first?
I'd be happy to start. So one of Kairos Power's hedges against programmatic risk is a strong focus on vertical integration. If we can't readily produce a component that we need, we'll manufacture it ourselves. And this extends to vessels, to fabricating our own fuel, machining our own graphite, and so forth. Raw material such as graphite is potentially challenging, but going pretty well for us so far. HALEU is indeed a risk. There's a solution. It's a viable solution, but it is moving more slowly, I think, than any of us would like. And I'll just add on and then wrap up to move on to somebody else. The human supply chain and regulatory infrastructure supply chain is a non-trivial risk, particularly if we want to scale to meet the emerging demand With regard to regulatory, we've had very good success on that front. And it's not to say that the NRC staff isn't doing a good job, at least for us. But to scale up to what we need, they're going to have to find additional efficiencies in their processes.
Jake, how about you?
Yeah, I mean, for time's sake, I think obviously I'll echo a lot of what Peter said. I think at the end of the day, one of the cool things about some of these technology types and designs being pursued is you can also leverage existing supply chains for other industries in many ways and many parts. There's a ton of value in that. It kind of changes how you think about the different approaches. Now, again, that's technologically specific and company strategy dependent, but that's a really important thing that allows you to sort of separate out from some of the supply constraints that have previously, I think, been somewhat challenging and risk driving for when we think about even small to larger scale light water reactors, especially large scale light water reactors. So there's some value in what that looks like. But I do think like fuel is a big piece of it. And I'll say this, like with the volume of what's coming, I think it sort of driven by market demand, it is going to drive a rethinking about how we just handle permitting as a whole, but not just nuclear. This isn't like, oh, energy permitting. I mean, this is a clean energy permitting challenge that, I think people have talked about. We're talking about vibrantly last year. I hope that conversation continues to progress because there are more efficient ways we can manage this. There are a lot of things we can do, societally speaking, to make this work better. If we unlock some of the bottlenecks that exist for permitting for obviously nuclear plants, but also transmission, distribution, just the whole ecosystem on this, as well as manufacturing and fabrication that we're trying to onshore, generally speaking, as an industrial base in the country, that's going to be a change. And it's not just throwing more people at the problem, it's bringing the people in, but also process improvements, efficiency improvements. But so I think there's some good ways that's going to be a major, I think, challenge to sort of scale to meet the opportunity set. And some of that does trickle in the near term to how we optimize what we're trying to do today, but not sacrifice what the future looks like in terms of the ability to accommodate sort of the pipeline that's coming to support all the demand we talked about.
Yeah. Well, Joe, how about you? I mean, your company's built more small modular, or at least small reactors than pretty much anybody else in the world at this stage. What are you seeing on the supply chain side that keeps you up at night?
Yeah, so over 400 and counting reactors delivered, and you're right. We addressed the supply chain very early on because we knew. Number one, we had to see, is the breadth of supply chain exist? I was pleasantly surprised that it did exist. The bench strength of the supply chain isn't as deep as we need it to be in the future, so we're developing that as well. And I talked about mass production. I mean, we're on-ramping several technologies now to prepare for mass production. If you're in a production scenario with microreactors and you plan to deliver one a year, just stop right now. That's just not going to work, right? So we know that, and so we're scaling that up. Now we've been manufacturing CHYO fuel for over 15 years, and now we will be manufacturing the fuel for Pele and for Banner, and so scaling that up in conjunction with scaling up the reactor production is something that I also focus on. So those two things go hand in hand: the fuel and the fuel supply. Peter already mentioned HALEU. When we get into mass production, we will need that readily available supply of HALEU, so we're participating in that as well. So for supply chain, once again, bench strength and ramping on new technology to get into mass production. Now on the regulatory front, through Pele, we have two regulators that are doing a fantastic job of integrating themselves and becoming very knowledgeable on what it's going to take to field this unit. One is the Department of Energy in Idaho, so that part of Idaho, the Fed side, has done a fantastic job of asking good questions, becoming intimately involved in what the technology entails, and then they will be well suited to go through the regulatory process. Same with the Army Reactors Office, right? They're standing that capability up. They're extremely knowledgeable with a great breadth of experience in that office. And how you use that information and the technical information that's required for regulatory is very, very similar in its content. It's just packaging it for the NRC. So we've started ramping up our engagement with the Nuclear Regulatory Commission on Banner. They are part of the Pele program and just watching how that's going. So I think converging that seems to be, I'm very optimistic about our ability to converge all three of those things. But the fact that we've gotten good feedback, we have great relationships with the regulator. The regulator is definitely well poised on the DOE and Army reactor side to make this real has been another pleasant surprise and another positive bit of momentum for Pele and microreactors writ large.
Thanks. Ben, you want to jump in?
Yeah, I think all of the ground's been covered. I know this is specific to each company, but similar to my colleagues, we took fuel manufacturing in-house because of the need to try to make sure that core part of how the reactor operates, basis of the design, is something we could have control over, make sure we could manufacture fuel at scale that was of quality. That said, we need the feedstock for it, and I'll say, to Peter's point, of course, we would love the department program to go as fast as possible, but they have seemed to have solved their capital issue and constraint, which is, now thanks to the great work of ANS and many other organizations, something like $3.5 billion that will be going to support the development of that supply chain for the feedstock that we all need. So that's a huge win for the industry, and I think really puts the U.S. Manufacturing supply chain back on the map for fuel. We also have things like graphite, right? There are only so many suppliers out there that have nuclear quality graphite and the data to back that up. And so there are other bits and pieces like that I think we could each talk about with our companies. I will just simply say that, to paraphrase somebody very wise, capital cures all ills. Nearly all ills. And so to me, actually, all of this is really a question of whether or not we can get capital to flow into this industry. We are seeing that through the investments in our companies, through the investments in the projects themselves. So that's a big deal. But really, supply chain is simply a game of capital as well. It's capital and timing. And so I don't think that this is a problem that will bound, the challenge of deploying reactors at scale in the 2035 to 2050 time period. For us, it's all going to be about how quickly we can ramp from our first reactors to kind of our max scale of build. And those are going to be, a number of different challenges that fit into that category. Can we deliver the projects on time and on budget? Do we have the supply chain that can scale rapidly enough with us? And are there any, NRC or NQA1 bottlenecks along the way? And do we have the people to go and put the steel in the ground? And that's a big one too, I think was mentioned earlier, but we are going to compete against the oil and gas sector. We're going to compete against the folks that are building data centers. We're going to compete against the folks that are building chip fabs, and any other areas of industry where we're making stuff in the United States again. But that's also true globally. So as we look to deploy these globally, it's going to be about scale of labor and quality labor to build nuclear plants as well.
Yeah. Thanks, Ben. Well, we just have a couple of minutes left, and I want to try to synthesize a couple questions in the chat about time frame. Now, first of all, I'm not going to put anybody on the spot in terms of their particular reactor. When is it going to be ready? When's it going to be, when's it light? I'm not going to go through timescales, but I'm going to ask a more general question and to try to get a sense of people's feelings on this. So my sense is that we're headed toward an inflection point, and it feels like that there is continued momentum to the development of advanced technologies that will start with demonstrations. But there will be some point in the future where we will say, the scale up has begun, and all the things that we are talking about are sort of solidified into reality. I think when people talking about an inflection point, that's what they mean. Now, I will tell you from my part, I've said it the last couple of years in the 2030 timeframe. Last 6 months or so, I found myself saying 2030-ish. Does anyone, give me your sense, and we'll go around the horn quickly. When will we know? When will we know that we've reached that inflection point?
I'll start. Yeah, we'll know when Pele's running, and it'll only be a couple of years from now. And I'm gonna give you a call, Craig, so I can use that shovel in the background to build the high throughput manufacturing facility for banners.
I am lending it out free of charge for anyone that's doing a groundbreaking. Absolutely. All right, let me keep going around the horn. Ben, do you have just a general thought on this?
I'd say it'll be kind of 2 dates. So we'll see it. Our Dow plant targeting CODs for all the reactors before the end of 2030, and that if that occurs, then the world will beat a path to our door to buy as many of these as possible. So that's kind of date one trigger point, I think, similar to what Joe said. Then how do we get to scale? That's going to be sometime a few years after that. I mean, we'll have deployed more units and CODs following, but we don't want it to be a linear deployment. We want it to be an exponential deployment. So that second date happens sometime, proof positive is going to be probably a few years after that, where you've seen the predecessor investments in supply chain to scale you're seeing the number of projects moving and ramping. So I think the evidence will be earlier, but if you want proof positive, let's call it kind of early 2030s, you should see an aggressive ramp.
Perfect. Peter?
My answer is going to be somewhere in the middle. Our Hermes series of non-power reactors will begin commissioning and start up in operation, in late 2026. And like others, I think once one turns on and is shown to operate and to be built, on cost targets, then it's going to be a real challenge to keep up with the demand. And we're targeting, 2030, 2031-ish as that floodgate. Just a quick sort of cautionary tale. We've been talking about how optimistic things look for several years now, and I'll warn all of our colleagues, the sheen is beginning to wear off a little bit on the hill. And so we're going to have to, and this is for all of us, we're going to have to perform. We're going to have to demonstrate real progress, and many of us are. The off-takers are also going to have to come off the dime and take a chance and start buying some plants as well. Once that first lean in happens, I think the sky's the limit, and the biggest problem, this is a good problem to have, will be keeping up with the demand.
Yeah. All right, Jake, you get the last word.
Okay, I'll be a bit different. I think the first inflection point's already happened. It's like watching an avalanche that's moving. You just have to know where to look, and it's triggered by a couple snowflakes. But that's happening. Like, I think we're already in that spot. So I actually think from the industrial markets and everything else, this is inevitable. It's just a matter of like, does this wave do this? Is there another wave that succeeds the ones here to do this? At the end of the day, this is happening. This transition is happening. So I think that inflection point's already in play. I think early plant deployments are actually they're important. That's fine. But the really important things are scalability metrics that I don't think you actually start seeing really matriculate till 2040, 2050 and beyond. That's not when you're building one plant. I mean, that's when you're talking about the scales that I think we're thinking about and we're alluding to. So I actually think that's where you really start to see a different perspective about making significant inroads because of the volume of deployment at the global side of things. And we've kind of worked through some of these bumps in the early part of the road. A big thing I'll say, we have to get out of the mindset that it's all about that first plant has to be perfect and everything else, because you're always going to fail on that. That's not the right thing. The thing is, how do you have a path to deliver that, learn from it, and apply those lessons learned to continue to improve so that you can hit an exponential ramp? Otherwise, you're going to spend too much time sort of over-optimizing for the wrong objective on that front. I think that's a really important framework that you've seen many other industries take and be successful with, and I think it's a challenge for us to sort of embrace that too. Because look, like all the factors are on our side. Like, let's go. I mean, it's the opportunities in front of us. It's just time to go execute.
Well, and that is a perfect way. That's a perfect way to end and to thank my participants today for what I think was a really, really good conversation. I'm going to invite you. I'm going to say one more final word, but I'll invite our guests to go ahead and disconnect and while I give sort of a little final closing here.